Alright, hey guys, it's Mrs. Boulanger here. So this is your lesson today on completing the square. To date, we've looked at how to find the zeros, and we've done a lot of that. How to solve by factoring, how to solve using the quadratic formula, how to solve by graphing, just locating those zeros on your graph. So for today's lesson, we're going to focus on a different part of our parabola. We're going to be focusing on the vertex. A lot of our application problems will ask you questions where you need to know that maximum or that minimum point on your parabola in order to answer the question. So if you're given an equation, how do you know what the vertex is? So we talked early on in the semester about vertex form, which is this guy right down here. We did him way at the beginning when we looked at all the transformations, and A gave us that reflect whether it was reflected or not, this vertical stretch or compression. H gave us that horizontal shift left or right, and K gave us our vertical shift up or down, and we discovered that our vertex is always that H comma K value. So if you're given an equation in vertex form, no problem, you've got your vertex. But what if you're given a quadratic equation in standard form? So like this guy. How would you then determine the vertex? So of course you could graph it and get the vertex out of that, but we know that sometimes graphing can be onerous, and sometimes our vertex might not be nice integer values. Our vertex could be decimals, decimal fraction values, so then it's a little more difficult to get it just by looking at a graph. So what we can do is follow this method called completing the square, and what that process does is take an equation in standard form and it converts it into vertex form. So after we do all these steps, it will look like this guy here, and you'll be able to figure out the vertex. It's a little complicated, but the steps are all lined out here for you. So if we follow along with this, it'll show you exactly how to complete the square. So I'm going to run through the first two examples with you, and then there are 4 examples on the following 2 pages that you can try on your own, and just following the model of this one. So the first thing we have to do is factor out the coefficient of the x squared term from the first 2 terms. So we're just looking at these first 2. -3, we're not going to touch that right now. When we common factor, we would normally pull out an x. We're not going to pull out the x here for completing the square, just that coefficient of the x squared term. So divide out 2, and my variables stay intact, -3. That's your first step in completing the square. Next step down, you have to grab this number in front of our x, and you have to divide it by 2 and then square it. So you have to do that common factor piece first before you grab that number. And this magic number is what's going to help us complete the square. Once we get to the bottom, you'll be able to see why we needed this number in order to make this work. So 1 squared is 1. Add and subtract that value being this 1 that I just calculated, inside the bracket of the equation 2 steps above. So we're going to grab that equation where I factored out the 2. And inside the bracket, I'm just going to throw in a +1. But that's going to change it. That's going to change my equation. So I'm also going to throw in a -1. +1 and -1 is 0. So I really haven't changed anything at this point. I've just added and subtracted an element so that I can manipulate this to work for me. So moving down here, I want to make this a simple trinomial in my bracket with the plus number coming first. I want to keep that plus number, which means this -1, I've got to kick him out. So in order to kick him out, I can't just remove him. If I could simply remove him, the world would be easy, but it's not always easy in math. To remove this -1, I first have to multiply it by this number out front. Because remember, the 2 is affecting the whole bracket. Every number in this bracket is being multiplied by 2. So before I can remove him, I need to multiply him by 2. So 2 times -1 is -2. That's going to get tossed out of the bracket. And your -3, of course, is there as well. Then we can go ahead and collect those like terms at the end. So we've got x squared plus 2x plus 1, and we have -5 on the end. Now, inside of this bracket, we have a simple trinomial, and it's a special simple trinomial. It's called the perfect square trinomial. And all that means is when I factor this, my 2 brackets are actually going to be identical. So if you go and try to find 2 numbers that multiply to +1 and add to +2, those numbers are 1 and 1. So just as a little side note for a second, I would write x plus 1 times x plus 1. They will always be identical. That's the purpose of completing the square, is that we get these two identical brackets, so then we can write it as one bracket squared being multiplied by itself. And that's the idea to get this thing into vertex form. We need that single bracket squared. So to get that down here, we just write y equals, the 2 is still there. We factor out that simple trinomial or perfect square trinomial, and we get the same bracket repeating itself twice, minus 5. Now, as a little trick that might help some of you who struggle a bit with factoring, this number we get here when we divide by 2 is always that number we're going to have here when we factor that perfect square trinomial. So it's not the last number, it's that middle step there just from the division. That might help you identify that number a little quicker. Final step here, the vertex is our h comma k. Remember, h is the opposite of what we see in the bracket because the formula is minus h. So that's a negative 1 and negative 5. And that is your vertex. All right, so we're going to move through the second example, and I'm going to go a little bit quicker. Hopefully you can follow along and not have to pause too many times. So we've got y equals, so I'm going to common factor out just the coefficient of the x squared here. So I'm going to pull out or divide out that negative 5, which leaves me with x squared minus 4x in the brackets, minus 16. So I need to now figure out what number I need to add and subtract in here that when I factor the simple trinomial, it'll work out perfect. So I need two numbers that multiply to something and add to negative 4, but I need them to be the same number. So that's where this step comes in here. Two numbers that add to negative 4 that are the same number would be negative 2 plus negative 2. But negative 2 times itself would be positive 4. And that's where this step comes in, finding that right number to give me that perfect square. All right, so now we put that number into our brackets as a plus and a minus. So we've got negative 5, x squared minus 4x plus 4 minus 4, and our negative 16 still outside. Now we are going to make that a nice simple trinomial in the bracket by kicking out that negative 4 from our brackets. But to kick it out, remember that these two have to be multiplied because that negative 4 is affected by the negative 5 at the front. So we multiply, you get positive 20, and 20 and minus 16, which I have over here, leaves me with positive 4. So I just simplified that piece up in one step. You can put plus 20 minus 16, you'll just have to collect them eventually. So moving on down, y equals negative 5. Now I've got that simple trinomial in the middle. I need to find two numbers that multiply to positive 4 and add to negative 4. And those two numbers are identical, making this a perfect square trinomial. Negative 2 times negative 2 or negative 2 plus negative 2. And you'll notice we see that negative 2 number up here in this step, that middle piece when I did that division. That's the number that ends up in your bracket. So it's squared because it's the same number twice. And final step, state the vertex, h, opposite of what you see in the bracket, comma k, number outside your bracket. And there it is. Now, from here, we can also find the zeros. So the standard form equation, we could factor it and find the zeros. That's one way, but we can also find the zeros from vertex form. And if we do it from vertex form, it doesn't require us to factor. It just requires us to solve by isolation, which we learned about the other day, because the x is in the brackets with the squared. So this is another way that you could approach finding the zeros. So of course, you can do it from here. Just factor this tricky trinomial here to get your zeros. But if we do it from the vertex form, so letting y equal 0, grabbing your vertex form equation, you're going to be able to solve this by isolation. So you add the 5 over, again, we've seen this already, this isolation method, plus 1x squared, divide by 2 to get rid of that a value, and that leaves you with x plus 1 squared. So this is just, again, another option. There are so many options of ways we can tackle these problems, which is probably what makes it challenging, that there's not just one way. But isolation is a little bit easier. So if you're asked to first find the zeros, or sorry, rather first find the vertex and then find the zeros, this is a way you can use that. So 5 divided by 2, complete that portion first, take the square root of that answer, and I get myself 1.58. Of course, remembering it's plus or minus because we're finding the square root. And then I've got to get this minus 1 to the other side. So 1.58 minus 1, or negative 1.58 minus 1, will give me my 2x values. So 0.58 or negative 2.58. So that's another option for how to get the zeros if you first get your equation into vertex form. So the guy on the right, grab your equation, set it equal to 0. Let me just make my pen a little thinner here. There we go. Negative 5, x minus 2 squared plus 4. And move that plus 4 over first. Negative 5, x minus 2 squared, just copying everything else down. Divide by your a. So negative 4 divided by negative 5, the negatives cancel. So you get 4 over 5, x minus 2 squared. Square root to get rid of your squared. So square root the left and right hand sides. And finishing it off, 4 divided by 5 is 0.8, and we take our square root, rounding it to 2 decimal places, so I get 0.89 or negative 0.89 for that square root. And then to get rid of that minus 2 here, I have to add 2 to the other side. And I get 2.89. And 1.11. All right, so there you have a method of how to change from standard form into vertex form. So if you check out the next 2 pages, there are 4 examples for you to try. It's really important, guys, that you try to do these ones on your own. The 4th example, or rather it's example number 6, the last example you do, you will get a fraction when you go through the completing the square step. That is what you're supposed to get, so don't let it freak you out. Give it a try. It's added there as a little bit of an extra challenge, and it is something that you will see next year in 11U. Don't let the fractions scare you. Give it a try. So do those 4, and then come back to the video, and I'll show you the answers. All right? See you in a minute. All right, so I got 2 minutes to show you these, so I'm going to make sure I flash them up and you guys have a chance to pause them. But the first half of both, I get negative 2, 13, and positive 3, negative 4 for the vertex. So if you need to here, if you've got different answers, pause the video and just compare your answers, maybe see where you've gone wrong. All right, so moving through this to the bottom portion, I'm determining the zeros for each. So I've just made the y value 0 and then solved for each vertex form equation, solved for each by isolation. You'll notice over here when I divide by the negative 3, those negatives cancel because we can't take a square root of a negative number. That would end up having no solutions. So we do need to make sure those negatives there are canceled out. Over here I just put NA because this one didn't have an A value. Okay. So you'll also notice too in terms of that one, so you can pause here if you want to look at that in more detail, but you'll just notice this one as well. It had that 1x squared in front, so we didn't really have to factor out the 1, but I just did it here so you could visualize what's happening. It is a good idea to have those 2 sitting in those brackets, even if you don't write the 1 out front, so that you can identify that you're grouping those and putting your calculated value here into the bracket. So for the next 2, here they are, 1 and negative 3, and negative 3 over 2, negative 11 over 2. So if you need to, pause the video right now, look over the details of those. And then finally, with the last step down here, determining the zeros, so making the equation equal to 0, and I have 9 seconds. Okay, pause the video here if you need to go over these. But other than that, if you have any questions about the fractions, come see me. Cheers!